All right, so this is the final lesson in Unit 5, Similarity. The lesson is called Parts of Similar Triangles. Okay, so suppose you have two triangles. Let's call them triangle ABC and triangle DEF, such that each side of triangle DEF is 3 times the corresponding side from triangle ABC. What is true about the relationship of their perimeters? Okay, so perimeters when you add up all the sides. So let's look at the perimeter of triangle ABC. That equals A plus B plus C. Okay, that's easy enough. Now let's look at the perimeter of triangle DEF. Add up all the sides, so 3A plus 3B plus 3C. Now let's factor out the common factor of 3, and you'll see that after we factor out the 3, what's left in the parentheses is A plus B plus C. And if you notice, that is 3 times the perimeter of the smaller triangle. Okay? So what that means is, if each side from this triangle is 3 times the corresponding sides from this triangle, then the perimeter of this entire triangle is 3 times the perimeter of this triangle. Okay? So I'm going to say the perimeter of triangle DEF is 3 times, should be the, 1 second, 3 times the perimeter of triangle ABC. So if each side is 3 times side from its corresponding, I mean, if each side is 3 times its corresponding side from this triangle, then this perimeter is 3 times this perimeter. Now that leads to what's called the Proportional Perimeters Theorem. Okay? If 2 triangles are similar, then the perimeters are proportional to the measures of corresponding sides. Okay? If 2 triangles are similar, then the perimeters are proportional to the measures of the corresponding sides. So, given that triangle LMN is similar to triangle QRS, find the perimeter of triangle LMN. All right. So what some people like to do is they like to write the perimeter inside the triangles. So we don't know the perimeter of triangle LMN. That's what we're trying to figure out. I'm just going to write an X in there. And let's add up these 3 sides. Let's do, to get the perimeter of the big triangle, we're going to add up the 3 sides. 12 plus 37 plus 35 gives me that perimeter is 84. So some people like to do that. They put the perimeters inside the triangles. You can do that if you want. If you don't want to do that, then just ignore that. So here's what we're going to do. We're going to write a proportion. I'll do X over 84. The perimeter of this one is X. The perimeter of the big one is 84. So I'm doing the perimeter here, X, over this perimeter 84, is going to equal 5 over the corresponding side to 5. Okay? So what side does 5 correspond to? Okay, well, first of all, 5 is on NL. So NL corresponds to SQ, which is 12. And now you're going to solve that proportion. Cross multiply 12 times X equals 5 times 84. 12X equals 420. which means that x equals 35. So that makes sense because the perimeter of this triangle should be smaller than the perimeter of this triangle, of course. So I'll say the perimeter of triangle LMN is 35, and since there's no units, I'll just write the word units. 35 units. Okay. All right, now this next page is going to look a little wordy, but don't worry, we'll make it easy. We'll make it as easy as we can. Special segments of similar triangles. There's 3 of them. Okay, this first one says, if 2 triangles are similar, then the measures of the corresponding altitudes are proportional to the measures of the corresponding sides. So your altitude is QA, your altitude is WU. Okay, those are your altitudes. I'm just going to jot that down. These are the altitudes. And these are the corresponding sides. Okay? The altitudes are proportional to the corresponding sides. So you can say that QA over UW equals PR over TV, which equals QR over UV, which equals PQ over TU. Okay? That's the first one you need to know. Second one, basically the same thing, but this one deals with angle bisectors. So if 2 triangles are similar, then the measures of the corresponding angle bisectors of the triangles are proportional to the measures of the corresponding sides. So QB is your angle bisector because it bisects angle Q, and XU is your angle bisector because it bisects angle U. Okay, so these are the angle bisectors. And again, these are your corresponding sides. Corresponding sides. And this last one, basically the same thing, but this one talks about medians. You learned about all 3 of these in the past. If 2 triangles are similar, then the measures of the corresponding medians, so QM is a median and UY is a median, the measures of the corresponding medians are proportional to the measures of the corresponding sides. So this is a median. These are the medians. And again, these are the corresponding sides. Okay? We're going to use that. We're going to use some of those in the next couple of examples. Just give me 1 second. Okay. Here we go. Example 2. Given that triangle ABC is similar to triangle DEF, okay, so you have to know they're similar. BG is a median, that's important. And EH is a median, that's important, okay? So we're basically going to be using this third one on the previous page. We're going to be writing a proportion. We're going to put the median over the other median equals one side over its corresponding side. Okay, so the 2 triangles are similar. BG is a median, EH is a median. Find EH. You need to find EH, so let me label that with an X. If BC equals 30, so this is 30. BG, the median, equals 15. And EF equals 15. Okay, so we're going to have to write a proportion. So I'm going to put this median over this median. So you're putting one median over the other. I'll do 15 over x. Again, make sure all your numerators come from one triangle and all your denominators come from the other triangle. So I'll do 15 over x, one median over the other median, equals 30 over 15. Because 30 corresponds to 15, because BC corresponds to EF. So that's my proportion. One median over the other median equals one side over its corresponding side. Cross multiply and solve. 30 times x equals 15 times 15. 15 times 15 is 225. So 30 times x equals 225. Divide that by 30, and you get x equals 7.5. But don't circle that. You want to circle EH equals 7.5. Okay. There are a few times where I make these videos where after I do a question, I'm tempted to say, does anybody have any questions? But then I remember that you're in a video, so nobody can ask me questions. Okay. Okay, now this next one is going to be a tough one. Example 3. Given that triangle KJL is similar to triangle EDC, DG is an altitude, and JM is an altitude, find JM and DC. Now, we're going to do this top one. We're going to do one altitude over the other altitude equals one corresponding side over the other corresponding side. So we'll do x over 2 equals 4 over 6 minus x. Let's solve that proportion. Cross multiply. X times 6 minus x equals 2 times 4. So we're going to have a quadratic. 6x minus x squared equals 8. So we want to solve this quadratic equation. So you want to get it equal to 0. And generally when you do that, you want to keep the x squared positive. So let me bring the x squared over to the other side. Let me bring the 6x over to the other side. And this is what I have right now. Let's factor that, okay? Find two numbers that multiply to 8 and add to negative 6. So it's negative 4 and negative 2, because negative 4 times negative 2 is 8, and negative 4 plus negative 2 is negative 6. Okay, now, so it means we're going to solve each one. You're going to get x equals 4. Actually, let me do out that work. I don't want to skip any steps. Okay, so I don't want to skip any steps. So x minus 4 equals 0. That yields x equals 4. X minus 2 equals 0, and that yields x equals 2. Now, we have to look and see if our answers make sense, okay? Let's see if the answers make sense. These are not the same. They should not be the same. Okay, these should not be the same. JM is bigger than DG, okay? JM is bigger than DG. If DG is 2, JM should not also be 2. So this answer we're going to disregard. Sometimes when you have the quadratics, you get answers that aren't actually answers, that don't actually work. We're going to disregard this one. We're not going to focus on this. Okay, so we're not going to focus on this one. I'll say let's ignore. Okay, we're going to ignore this one, okay? Because JM should not be 2. JM should be bigger than 2. So we're going to do this one. X equals 4 is the answer we're going to go with, okay? So we're going to go with x equals 4. Find JM. Well, JM equals x. So Jm equals 4. And find DC. DC equals 6 minus x. DC equals 6 minus 4. DC should equal 2. Okay, one more theorem, and then 2 more examples on the theorem, and then we're done. Okay? The angle bisector theorem. An angle bisector in a triangle. So this is the angle bisector, CD, because it bisects angle C. Separates a triangle. An angle bisector in a triangle separates the opposite side into segments that have the same ratio as the other 2 sides. So we can say that AD over DB equals AC over BC. So I just think about it like this. If this is the angle being bisected, look at the side across from the angle being bisected and put one over the other. So for example, AD over DB equals AC over BC. Make sure all your numerators come from one triangle and all your denominators come from the other triangle. Okay? So for example 4, find SR and ST. Let's take the angle being bisected, which is angle S, that's being bisected. Let's look at the side opposite that. And let's put one over the other. Okay, so I'll do 7.5 over 12.5. 7.5 over 12.5 is going to equal x minus 5 over x plus 5. Again, make sure all your numerators come from one triangle, and make sure all your denominators come from the other triangle. Now let's cross multiply and solve. Distributes. (12.5x minus 62.5 equals 7.5x plus 37.5. Let's get all the x's on one side. So 5x is going to equal 100, and x is going to equal 20. Great. Now we can get SR and ST. SR is going to equal x plus 5. So SR is going to equal 20 plus 5, or 25. And then let's do ST. ST is going to equal x minus 5. So 20 minus 5 is 15. One more problem with that's coming from the same theorem. So let's take the angle being bisected. Let's look at the side opposite that and put one over the other. So this is the angle being bisected. This is the side opposite that. Put one over the other equals x over x plus 4. Make sure all your numerators come from one triangle, and make sure all your denominators come from the other triangle. That looks a little messy. Let me rewrite that. Okay, that looks better. Okay. So we're going to cross multiply and solve. Let's do x times x plus 2 equals x minus 1 times x plus 4. So on the left, you're going to distribute x squared plus 2x. And on the right, you're going to have to distribute twice. Okay. First, you have to distribute the x. Then you have to distribute the negative 1. Okay. So we're distributing twice. The x. So x squared plus 4x. Then distribute the negative 1. Minus x minus 4. Let's combine like terms on the right. So x squared plus 2x equals x squared plus 3x minus 4. Now, you may get a little worried right now with the quadratic terms, but those are going to subtract out. Subtract out the x squareds on each side. Those go away. You get 2x equals 3x minus 4. Perfect. No quadratics. Solve this for x. Subtract 3x on each side. Negative x equals negative 4. And that gives x equals 4. So that is the end of lesson 5, parts of similar triangles. And that is the end of unit 5, similarity.